Okay, so something I want to mention right here that I forgot to mention in our last video at the end there is I left it at the setup moment for evaluating that integral. I am going to get a different answer than 32 divided by 5 as in the previous run at cross sections that were in a different orientation. This is 6.4. If I were just setting it up, I could leave it where I left it. If I had a calculator, I could make the calculator give me that answer. And if I had to actually find the answer by doing this in a no calculator zone, I would have to square that binomial. I would have to find the antiderivative evaluated at 4 and 0. And I'm going to be honest here, the moment that you actually earn full credit on the no calculator section is right here. You guys have been really, really good at picking up at that. Don't feel the need to go further. This would be fantastic. This would be fantastic. And of course, this is fantastic. I'm going to try in the space that I have remaining here to do one last problem. And sorry for giving you motion sickness here, but I'm going to try this cross section here that where the cross sections are semicircles. So look away as I scroll up. So we're going to do the same region here. We're going to take cross sections that are semicircle. Cross sections are semicircles perpendicular to the x-axis. So that's going to be our last example here. That's what it looks like is being shown in the imagery that you have. So I'm going to sketch it, because I have to sketch a new region every single time. I'm going to draw my cross section in there, which is semicircles perpendicular to the x-axis. I like to see it in here. But definitely, when I look at this volume, it's going to be the integral of the area of the cross section, which is a semicircle. That is 1/2, let's see, times pi, times the radius squared. Let me just write it like that. Now, I'm definitely going to have a dx here because that rectangle in the shaded region is drawn vertically. So it's definitely dx. What I have to tackle is the radius, right? This is the radius of this circle. So I want to be really clear that the radius is only half of that rectangle. So that's only half of what I'm calling, hey, the whole side. So when I go to this volume formula, I just want to be clear about what's happening. I can pull the 1/2 and the pi out of the integral. Don't let that bother you. But the r value is half of the side length. So I want to be clear about that. Now again, my side length is top minus bottom. It's the y coordinate up here, which could be anything, and the y coordinate down here, which is 0. And for this particular problem, I know my integral has to be in terms of x, so I'm going to replace y with x squared. So my volume formula in here has a pi because it's a semicircle as my cross section. That's why. Now I have a 1/2 x squared minus 0, and I'm squaring the whole quantity in here. So I want to be clear. I want to make sure that you have this. You are squaring the fraction of 1/2, and you're squaring the x squared. So what you see oftentimes on a volume with a semicircle is you see a coefficient outside your integral of pi over 8, and I just wanted to be super crystal clear of where that is coming from. That is 1/2 pi times 1/4. And then what I have in here is x to the 4th dx. So I definitely wanted you to see that. You could definitely evaluate it if I needed to. The only thing that I'm missing on here for full credit of the setup is limits of integration. And I know I'm supposed to get them from the x-axis. That would be 0 and 2. This is low.